Okay, good morning, everyone. First, make sure that the packages are already installed. So let me run this. Okay. And then we said that we're going to make use of the wage data set. Make sure that the wage data set is loaded in your in your R project, making it easy to access it. So here I'm creating this object wage. And then I'm using the read underscore CSV. This is from readr or from tidyverse. And then just identify the name of the file. Otherwise, if it was saved in another location and not in the our project itself, then you would have to have identified the location, the folder or the directory where it's found. Okay, then we have to identify that this file has columns. Okay, so I'm going to run this to control enter. You have a print. Okay, so these are, oops. Okay, may kasama pang integer dito. No? I'm just going to delete this class. So wage out minus, and then select ko na lang select. So you'll start with the wage, control shift N, select. I'm going to delete this first one. So it's from 2 to 9. Select 2 to 9. Okay. There. So I'm now creating wage class. And then this wage is coming from wage. And then I'm just selecting columns 2 to 9. Okay, control enter. So if I check now, wage now has, okay, from education to hourly wage. Okay, could you kindly please chat if you got that class? Maybe you didn't have that wage where you have the number one, but just make sure that this is your wage data set, education up to hourly wage. So kindly check and please chat yes if you're okay. Make sure that this is your wage data set. Feedback, please, class. Okay, thank you. Let's wait for the others. Make sure your wage data set is loaded. It should appear here, class. When I say loaded, it should appear here. You should be able to access this because this is the data that we're going to use to model. So let's give your classmates a few more seconds. Okay, great. Thank you. Thank you so much, class. Okay, so going back here. Okay. So we know that our wage data set, if you take a look at the structure, it's a table. And the variables that come with it are education, dollar experience, tenure. Okay, some variables are character in nature, the race, gender. And here you have civil status, okay? And then number of dependents is numeric, and then hourly wage is numeric. So for the character variables, we can check the number of levels. For example, for race, we know that we can use a table function, wage, our data is wage, and then dollar race. So non-white 54, white 472. Let's take a look at the other one. Table, and then wage, and then dollar, gender. So female 252, male 274. And then lastly, table, wage, dollar, civil status, tab 320, married, 206, single. So those are our three variables that are categorical, or they're character variables. However, they're a special type of character variables because they are what we consider as factors. Factors are character variables that can be used for classification, for classifying. So for example, we can group by or classify female and male, married and single, okay, etc. All right. And then we said last time that you cannot actually get the mean of education because education is not found in your environment. You only have wage. So if I run this mean of education, it will give us an error term. Okay. Ay, wait ha. Kasi napalitan ko na class yung wage ko eh. Okay. Kindly tell me class what you got class for mean education. Did you get the value 12.56 when you get the mean of education class? Or did you get an error term, an A? Feedback please, class. Class, please. Ang tagal ng response time natin, class eh. What do you mean by yes? You got this? What do you mean by yes? You got an A or you got 12.56? I don't get the oppo, no? 12.56. Are you sure? Bakit 12.56 class? Ito, I mean, mean of education ito Not the second one class. This is what I'm asking. Mean of education. Are you getting 12.56 or are you getting an A? Error. Iba class? About the others? Error? Okay. Yeah, you should be getting an error class if you get the mean of education. Why? As we said before, R does not recognize class of education. It's not in our data. No? It's not listed as an object here. So in order for you to access this, you should do this class, mean of wage education. Okay. If you now try to get the average of education, but you have to identify that this education variable is coming from the wage data set, then you should be able to get this. Okay. Now kindly run this class and tell me if you were able to get the average of education. Hello, class. Okay, so sabi natin class, we said that in order for us to let's say compute the mean of a particular variable, kailangan idaan natin sa data. No? But in my case class, tingnan nyo nag-mean of education ako. bakit lumalabas yung answer? In your case, it does not, no? It does not, class. You can do this, class. You can get, let's say, the average or the whatever computation of the variable itself. Kasi I did something here. I run attach, then wage. Okay, so this is the function, this is the code that I run so that I'm able to access the variable themselves without having to attach wage and then dollar. So if I run this, attach wage, control enter, and you may try it if you want lang, no? Kasi hindi ko alam kung magre-respond kayo, no? Mean education, ayan, nakuha, no? Yung mean education. Okay? So naka-attach yan, class, no? So for example, if I get the mean of experience, pwede yan. Mean of experience, it will solve that. Or variance, gawin natin variance, var of experience. It will be solved, class. Yan, 184. Kasi nga, na-recognize to ni R, kasi I attach education, I attach wage. Okay? But class, you only do this pag kunyari isang data lang yung inaano nyo, no? Kasi if you're working with several data, mahirap din to kasi ang laging titinan niya si wage, no? So if I want to detach, pwede ko rin gawin yun, detach. Kung na-attach ko, tapos na akong gamitin si wage, I can detach that, and then, so naka-detach na si wage, ano? Yan, no? Nakarana, detach wage. And then I run var. Okay, oops, ano nangyari? Wait, hindi ko yata na ano to. Detach wage. Okay. Bakit ano? Dapat hindi na siya mag-run. Control enter. Ayan, error. Hindi niya nabasa kanina to, class. Yung detach. Ayan, error, object experience not found. Okay? All right? So you can attach and detach. Okay, if I attach again, ulitin ko attach wage. Ayan, naka-attach na siya, di ba? Here, take a look at my console, naka-attach siya. Kunin ko ulit si var, variance ng experience. Mag-run ulit siya. For the last time, i-detach ko ulit siya, detach wage. Okay? Okay. Dali ko ang class, may knock on the door lang. One minute, class. Pause recording ko lang. Okay, so attach, detach. Okay, so if you're working on this data, si wage, tapos talagang ito lang talaga yung wage, ito yung talaga yung data na work on yun, then maybe it's good to attach it. However, just remember that if you're going to work on another one, i-detach yun siguro para hindi magkakaroon ng confusion. All right, so last time we did this, di ba? We said that it's important for us to generate a correlation plot. Kasi one of the requirements ng classical linear regression model is that your independent variable should be highly correlated with your there should be relationships between your dependent and your independent variable. So what we did last time was to use the Peirce-Panos function coming from the psych package, and then wage. And then this is what we got. Quick review lang to, class, kasi diniscuss natin to, no? And on the upper part, you have your correlation. Okay. On the lower part, you have your wala yung class, my glasses. Where did I put it? Okay, anyway. So correlation here. And then here is your scatter plot. And this is your distribution, no? The plot of the variable itself. Okay, and we said that this one, yung race, education, yung correlation niya does not mean anything kasi si race, gender, at saka civil status, these are character variables. So ang ginawa lang dyan, kinonvert lang into numbers yung race, gender, civil status, kaya nagkaroon siya ng correlation. So we don't want that actually. So maybe what we did last time was to create another object, wage1, okay? And then coming from wage, we selected the numerical variables, education, experience, tenure, number of dependents, hourly wage, okay? So I create this. So may wage1 ako dito class sa ilalim. 5 variables lang siya. Tinanggal yung mga, we remove the categorical variables. And then, I once again did the pairs.panels. And you can see now that, okay, you only have here the relevant variables. Okay. So another way to do this is to make use of the GG pairs function from GG ally. So I'm going to run this. Okay, this is a lot better than the pairs.panels. So let's focus on that. There you go. Okay. So this one is better than the pairs.panels because you have here the variables on the top row and on the left column here. You can easily see the correlation. So for example, the correlation between hourly wage and education is 0.406. You also have the statistical significance, 3 stars, which means they're highly statistically significant. Those that do not have stars there mean that they're not statistically significant. And here you have the plots. Also in the diagonal, you have the plot of the variables. Here also you have the scatter plot, just like the pairs.panels. Only this is a lot better, at least for me, in terms of the presentation. Okay, so I think last time, I'm not sure if I discussed with you, but let me just go through it again. So first we'll have an example of simple linear regression. For simple linear regression, you only have one independent variable. Of course, you have one dependent variable. So you would try to explain the relationship between your sole or one independent variable with your dependent variable. So here we're plotting it first. Okay? Okay. If I, for example, if I attach, okay, if I attach wage here, okay. So what we can do here is that we can plot already without identifying the wage. Okay. R will understand this. Okay, attach wage and then plot. The first one will be your x-axis, and the second one will be your y-axis. And the title of the plot is scatter plot of education and hourly wage. So running this, we have this plot, okay? And we can see here that there seems to be a correlation between your hourly wage and education, and it's positive, which means that as education increases, your hourly wage also increases. This is similar to the plot we had a while ago, this one. Ito yung plot na yun, education at saka yung hourly wage. Ito yan, no? This one. Okay? So, we now go to our regression class. Okay. Unless you have any question, you have any clarification here? Okay. None. I won't I won't class give you so much anymore time, no, for ano, kasi hindi kayo kagad nagre-respond eh. So kung gusto ko, kung may talagang question kayo, para hindi ako nag-waste ng time, magtanong kagad kayo, no? For clarification. Otherwise, I will assume that it's clear. Okay? Knowing that you don't respond anyway quickly to my queries. All right. So let's now create this model. Model 1, LM stands for linear model. So this one should be your dependent variable. This one, tilde, means association. The association between hourly wage and education. This is similar to your regression. No? We're regressing hourly wage on education, and then data is equal to wage. So even if you have attached wage here, you still have to write this one, data is equal to wage. Okay, let's run this first mod 1, control enter. Okay, and then let's take a look at what's here in your so tingnan natin dito guys sa data, no? Mod 1. If I click this, okay, ano laman itong mod 1 na to? So there are, okay, minimize ko muna to, no? Yan. So list, labing dalawa, no? Yung LM function natin. 12 items, elements inside this mod 1. What's inside this one? Andyan si coefficients. Ito class, yung result ng regression model natin. Double, dalawa, no? Residuals, andyan siya, 526 observations all in all. Effects then, as to what these are, we'll discuss as we go along. Then rank, fitted values, 526 din. Ito yung ano class, ito yung predicted values. Okay? So yung actual values minus your fitted values, that's your residuals. Okay? Yung fitted is your predicted. So as a sample lang, tingnan natin ha. So, ang hourly wage natin, yung una is 310. Ba? So let me copy this. Control C, 310. Control V. Okay? Tapos, the first, yung predicted value natin sa unang observation, sorry, is 5.05. So let me copy that, 5.05. So that was our predicted value. Okay? So ang actual value is 310. Here, hourly wage 310. Ang predicted value is 5.05. So if I run this, I get the difference between the actual minus the predicted, control enter, negative 1.95. This is your residual class, your error term. We're comparing the actual minus the predicted, it's negative 1.95. And you can see that here in the residuals, yun. Negative 1.95. Okay, siguro another one, last one. Ano yung actual natin sa second observation? Okay, 3.24 siya, no? 3.24 yung actual value. And then, how much was the predicted value? Predicted natin is here, fitted value, 5.59. 5.59. So, over pa rin, ano? Mas malaki. Negative yung ina-expect natin dito na residual. Control Enter. Negative 2.35 yan. Rounding off lang. Negative 2.35 yan. Okay? So, the residuals are the error terms. Okay? Yung fitted values class are your predicted values. The actual are here. Nasa wage natin. Okay, so that's our model 1. No? Model 1 object. So let's summarize class kung anong, what's inside this. By the way, class, you can run this names ng mod 1. And it will give us the elements of mod 1, yan, di ba? Okay, coefficients, residuals, etc. You can, in fact, class, get mod 1 dollar residuals, this one. If I print that, control enter, there, class, it will give us yung what's inside this, yung negative 1.95, etc. There are 596 ilan ba to? 526 observations, so 526 values to. Okay? So the mod 1 object contains very important information, data about the model. Okay, so here we were able to show that we can print yung mga residuals. You can also print the, okay, print natin mod 1 dollar fitted values. Mod 1 dollar here class. Don't have to type it, fitted that values. Control enter. Yan. Yan yung mga fitted values class. Okay? In fact, class, if we get, diba, if we get the wage dollar, ito class, hourly wage, no? So that's the column of the hourly wage minus model 1 dollar, then the fitted values. Okay? Ito class, no? Ito, actual values minus fitted values. Run natin, control enter. Okay, this is actually your, ayan, ito yung mga residuals natin. So just to show you na, yeah, ito nga yung mga residuals. Diba? All right. So, summary class, summary model 1, tingnan natin. Control enter. Okay, so this is now the okay, this is now the result. So first we have call. The call here is the formula that we used. LM stands for linear model hourly wage regression education. Data is equal to wage. Ito yung formula natin. No? So this is just a simple linear regression. Iisa lang yung predictor natin education lang. Residuals class, this is the descriptive statistics for your residual. Minimum residual, first quartile, second quartile, third quartile, and maximum. May malaking residual, 16.6. Okay, coefficients, take a look at this class. Ano to yung coefficients na to? Let me run this again. Control enter. Okay, there you go. All right. We're not going to discuss this in greater details kasi simple linear regression lang to. Ang gusto natin, i-discuss natin yung multiple linear regression. So, wala masyadong relevant sa atin tong simple linear regression. I just wanted to show this to you in order to show you how R does the regression. But this one, I'm going to share with you, class. Okay. So, for example, close ko lang to, no? This one, I have this LaTeX, Control C, LaTeX formula. Okay. LaTeX formula class. So, take a look at this. So, this is the formula for your slope. Ito yun. Saan yun? Wala. Yung summary mode 1 natin. Ito class, ito. 0.54. That's the formula for your slope. This is how it was generated. So, tingnan natin to very quickly, class, just to understand what this formula is. Recall from your basic stat, ito class, x minus x bar times y minus y bar, and then isa-sum up mo siya. Actually, ang complete formula niyan is divided by n minus 1. N minus 1. So this is the formula for covariance. So you're getting the cross product of the deviation from the means of your x and y. So dalawang variables yan, di ba? So you can write that as covariance xy. Covariance xy, covariance yx, they're the same. Or you can write it as sigma xy. Yan. Same thing lang. Covariance xy, sigma xy. And then this one class, the denominator, summation of x minus x bar squared. Diba? So if we have this also divide by negative, divide by n minus 1, this is actually class, what's this? X minus x bar squared over n minus 1. This is the formula for what? Formula for, okay, sasagutin ko na lang class kasi baka na naman umabot tayo na 5 minutes, no? That's the formula for the variance of x. Okay, so recall nyo lang sa ano nyo, basic stat, no? The formula for the variance is just x minus its deviation from the mean squared summation divided by n minus 1. Okay, so this is the variance of x. So, since we have the same denominator, pwede i-cancel to. So you're left with this one. So this one class is actually the covariance of x and y divided by the variance of x. So that's the formula to get your intercept beta 1. Okay, so very quickly now, let's just show this in R. So gamitin natin tong, okay. So ang formula natin, di ba, x minus x bar. So we can create this object x1, which is education, yung wage education. So that will now create a vector ng values ng education. Tapos ito, let's let x bar be the mean of this mean of the education, no? Average siya. Okay, so if I run this class, okay, take a look at the data here. So x sub I. Okay, so these are just the values of your, diba, education, no? And this is the mean of education, and they're all vectors in these data frames. Okay, ganun din class, kailangan natin si hourly wage then. So here I'm creating this object y sub I, which is just hourly wage, no? And then we also get the mean of hourly wage. Okay, in the interest of time, I'll just copy this, Control C, and then just share it with you. Okay. So, yung formula nito class, sum ng, this is education minus average education times hourly wage minus average ng hourly wage divided by, this is the variance of education. Yan. Okay, so if I run this, run ko muna tong apat na to in order to generate yung x sub I, y sub I, x bar, y bar, and then compute for the beta. Okay. Which is just the sum based on the formula, di ba? Sum ng cross product ng x sub I ng x minus the average x times y minus average y. Okay, and then divide it by the variance of x, which is summation ng x minus x bar squared. So this is actually class just a review of your prior elementary statistics. No? Okay, sige nga class, pakiran kung ano yung nakukuha natin na beta. Is it the same as the beta, yung 0.54 that we got from the regression line class? Okay, it's the same, no? Okay, so I hope the others are following along. All right, so that's your beta class. In fact, class, run ko to Control Enter. Yeah, 0.54. And if we compare that with the Control Alt I, i-compare natin siya class dun sa ano. So, tingnan natin si mod 1. Mod 1, dollar. So, coefficient siya class. Coefficients. A while ago, class, nung tinignan natin si mod 1, diba? When we looked at mod 1, coefficients, dalawa. No? Yung una, ito yung intercept. Yung pangalawa, ito yung slope, yung 0.541. So, if I'm going to use this one, mod 1, and then coefficients, so dalawa yan, di ba? What I need is the second one, which is the intercept, the slope. Tingnan nyo yan, class. Run nyo yan, and let's see if you get the, you should be getting the same. 0.54 then. Okay, if I run this, yeah, pareho din. Kasi we're just extracting it from the mod 1. Mod 1 object. Diba yung mod 1 class? That's the regression model. Ando dun lahat class. Andun yung coefficients, andun yung residuals, andun yung fitted values. Okay, so you just have to extract that. So ito, no? In-extract lang natin. Okay? Ito yun. All right. Or class, Kasi pwede naman natin ginawa to, di ba? Yung attached wage na to. So, pwedeng pwedeng hindi na wage dollar education minus mean of education. Okay, so ito, I'll just control C, I'll just share this with you. Another way to go about it, you just get the same answer anyway. So it's just making use of the attached function so that we don't have to use wage dollar education here. Diba ito yung X natin, wage dollar education. So using the wage, attached wage, you can just use education minus mean of education. So this is your X minus X bar. And then your Y is hourly wage minus mean of hourly wage. Okay, close. So may sum tayo dito. And then divided by the sum of the variance of your X, education minus mean of education squared. All right, so we can run this now. Naka-attach pa yung yung sa wage. Then R will understand this. Okay, ano sabi dito? Ba't ako nag-error? May mali ba ako dito? Control enter. There, 0.54. Okay? 0.54 siya. Okay, and another one, class, I just want you to write this. Ito yung sinasabi ko kanina na yung slope natin is simply equal to the covariance between your X and Y and the variance of your X. A variance ng independent variable. Try nyo, class, no? If you get 0.54. Okay, if you want to comment, yes, then okay. If not, then I will not, para hindi ako mag-expect. Okay? All right. So kung may mga questions na lang, may questions? Kung wala, I'll proceed. No? Okay. All right. So how about, class? Kasi nakuha na natin intercept, slope pala. You can also get the intercept, class. Control C. Pag may question kayo, chat na lang, no? All right. So you can also compute for your beta null. Yung beta 1, class, ito yung slope natin, slope for education. Ito naman, beta null, this is your intercept. This is the value of your dependent variable, okay, hourly wage, if your dependent variable is equal to 0. So that's what that means. Okay, we'll discuss that in greater detail when we go to multiple linear regression. And the formula is the intercept is equal to the average Y minus your slope times your average X. Okay, so that's very easy to run here in R. So our beta 0 is equal to mean of hourly wage, that's your Y bar. So it's okay not to put the dollar sign there. Okay, and then minus B1, we have already computed this. This is your slope, and then multiply that by your mean of education. Okay, so I'll run this, class, and it's negative 0.904, and you can actually access that, class, compare it with model 1 coefficient, and then the first one, because the first one will give us the intercept. Okay, and if we run this, you get the same one, intercept. Okay, I'll give you a few seconds to your copying. Okay. Okay, I guess there are no questions. Okay, so let's continue. This time, class, let's go now to the real regression, the multiple linear regression. So this is now model number 2. Let's now regress hourly wage, our dependent variable, on all the other independent variables. So take a look at how this is done. So I'm creating model 2, LM, once again, our dependent variable hourly wage regressed on. So let's identify all the other independent variables: education, experience, plus tenure, plus race, plus gender, plus civil status, plus number of dependents, and then identify the data is equal to wage, and then get the summary of model 2. I'm going to give you a few seconds to type that and then run that, and then we'll discuss. Okay, yeah, so take a look at this class, no? Model 2. Take a look at the structure of the equation. So we're creating model 2, LM once again, hourly wage regressed on the other variables. The shortcut class is this one. It will give us the same result. LM hourly wage tilde and then dot. The dot here means all the variables. Okay, all the variables. So this is handy. This is convenient if you have, let's say, 20, 30 variables as your regressors. So this could be convenient. Okay, but ito okay lang naman. No? For pag konti lang siya class, I suggest that you do this para nakikita natin yung ano yung ito nga sabi natin, if it's really very many variables, then you can do this to save on time. Okay, so let's run this first class, model 2, control enter. And then once again, take a look at this class, model 2. And it's also a list of 13. So there are 13 items here. Yung sa number 1 natin, 12 lang. No? So yan, list ng 13, LM natin. And what's inside here, yung coefficients din. Okay, so take note. Ang coefficients natin ilan dito? 8, no? This one, so this is your intercept, and then these are now the slopes for each of the independent variables. Then you have your residuals, same thing with the one a while ago. There are 526, and then there are fitted values 526 also, etc. Okay, all right. So that's what's inside your model 1, model 2. I mean. And then if we summarize this now, class, summary model 2. Okay, there you go. All right, so let's take a look at this class. So once again, you have the call here. This is our formula. This is the residuals, descriptive statistics. Okay, notice class, kanina 16, di ba yung maximum na residuals? Ito lumiit, 13.91. Okay, now let's take a look at this first. So intercept, education, experience, these are your predictors, diba? Independent variables. So let's take a look at them quickly. Okay, so let me annotate here. All right, first is education. So there are certain details here. So this is your estimate. Okay, this is your standard error. This is your T value, and this is your P, and then take note, 3 stars. So this has something to do with the significance of your variable. Okay, let's analyze this first. What's the meaning of 0.57? Okay, 0.57 is the marginal effect of education on your dependent variable hourly wage. So this tells us that for every one year increase in education. Okay, now why did I say 1 year increase in education? Because the dimension of education is yearly. So yung mga data natin dyan, years. So you have to interpret that slope class consistently. Whatever the dimension of your dependent variable is, independent variable, kailangan yun ang gagamitin mo. No? So this is saying that for every 1 year increase in education, notice I said increase in education, there's a corresponding $0.57. Okay, why dollars? Kasi class, yung hourly wage natin is in dollars. No? So I'm reading this in dollars. Okay, so for every 1 year increase in education, there's a corresponding $0.57 increase in hourly wage. Bakit increase? Because it's positive class. So we're saying that there's a $0.57 or 57 cents, $0.57 increase in hourly wage, then comma, don't forget this, CP. So CP, what does that mean, class? Ceteris paribus. What's the meaning of ceteris paribus? All things being equal or all things being the same. What's the meaning of all things being the same? It means, class, that, as I was saying, for every 1 year increase in education, the other variable should not increase. We're only letting education increase by 1 unit. That's what we mean by ceteris paribus. Okay, we're not taking a look at the changes also from the other variables. We're just taking a look at the 1 unit increase in education. 1 unit increase in education is equal to 1 year increase in education because the unit of education is in years. That's the dimension. Okay, so it's 0.57 class. So which means that if education increases by 2 years, then this should be 0.57 times 2. No? So the hourly wage will increase by 0.57 times 2 kasi 2 years increase in education. Okay, now the question is this increase in education in hourly wage based on 1 year increase in education, is this statistically significant? Okay, which means that is it possible that this is just this was just a result of an anomaly or nagkataon lang to? Nagkataon lang siya, no? Hindi siya talagang 0.57. Okay, where do we go to find the answer? We go to look at the t value or the p value. So that's where we look at in order to determine if this marginal impact, if this slope is statistically significant or not. Okay, how do we interpret this? Take a look at the 3 stars here and i-reference natin dito, class. So 3 stars here is 0.01. 2 stars is 0.01. 1 star is 0.05. That is just 0.1. And then nothing, that's 1. So it means, class, that this education, the value here is statistically significant at 0.001. It means the probability, okay, is less than 0.001 kasi yan ang ano niya, yan ang ito yung statistical significance niya, no? Okay, if there were 2 stars here, ibig sabihin ng class, statistically significant lang at 1%. If there's 1 star, class, it means it's statistically significant at 5%, which is usually the benchmark. Okay, if there's a dot here, class, dot lang to, no? It means it's statistically significant at 10%. Kasi may mga subjects class na okay na sa kanila yung ano, yung 10% statistical significance. If you take a look at this one class, this is a dot. Ibig sabihin, this one is statistically significant at 10%. 10% siya. If you take a look at the p-value class, di ba, 0.07, less than 10% siya. Hindi siya nag 1 star, okay? 1 star sana siya class kung less than 0.05 siya. Hindi eh. If this was 0.044, then it would have been given a 1 star. Ibig sabihin, significant at 0.05. Okay, so that's the meaning of this. No? Itong 3 stars na to, significant yan at 0.1% or 0.001. Okay, ano ibig sabihin ng significance class? Ito kasi class, may statistical test dito. No? Okay, let's take a look at education, 0.57. Statistical test yan class. So, we're testing a null hypothesis here. Ang hypothesis niya is that B1, which refers to the slope of education, is equal to 0. Yan ang null hypothesis niya. No? Tapos ang alternative, so of course, B1 is not equal to 0. Okay, so ano yung ano dito? Ano yung inference natin? So our inference here is that, okay, we, ano to class? Fail to reject or reject the null hypothesis? Are we rejecting this null hypothesis that B1 is equal to 0? The answer is, are we rejecting that class? The answer is yes, we are rejecting the null hypothesis that B1 is equal to 0. Why? Why? Kasi based on the p-value is, ito, ang liit-liit sa 0.00000, 15 zeros and then 2. No? So that's this number. So that's practically very much less than 0.001. Kaya nga significant siya at 3. No? Significant siya at 0.001. Okay, 3 stars dito. Okay, so we're saying that we reject this null hypothesis. There's strong statistical reason to believe that your B1, your slope for education, is not equal to 0. In fact, the average value is 0.5745. 0.575. That's the average value of your marginal effect of education on hourly wage. For every 1 year increase in education, hourly wage increases by $0.57. And that's statistically significant. So you either look at the t-value or the p-value. Today we're looking at the p-value. We can take a look at it also from the t-value perspective. They give the same answer. Okay. All right, let's go now to another variable here. Take a look at this class, gender male. What does this mean? What's the meaning of gender male? Now take note, class, gender. Let me clear the drawings. Okay, gender, asan na si wage natin? Close this. Okay, gender class ito. No? So si gender class, female, female, male. Let's take a look at the, kanina nag-table na tayo nito, di ba? Table, let's take a look at the cross tabulation. Wage ni natin. Naka-attach na kasi sa wage, no? So, although hindi siya nag-up yung wage ko na lang. Kailangan makita natin intelligence. Wage ni gender. Okay, so there are 252 females and 274 males. Now, take a look at the result. Medyo kakaiba yung result nito. Tingnan nyo. No? Different. Ito. Gender male. 1.75. Tapos statistically significant din siya. Statistically significant at 0.001% or 0.1%. No? Sorry, 0.001 or 0.1%. Okay, so ano ibig sabihin nito, class? In order to understand this, okay, we have to understand that gender is a categorical variable. Okay? Not only a categorical, it can be considered as a factor. Kasi not all categorical variables can be classified as factors. Ang factors class pwedeng i-classify. Okay, that's a term used pag factors class. It's a categorical variable, character variable that can be used as a classifier. So pwede nating i-classify among genders, which is female and male. Okay, so what happened here, class? Okay, pag ganyan class, pag categorical, pag character variable, what will happen is that R will convert this into a, okay, so itong gender, no? It will be converted into a dummy variable. Dummy, D-U-M-M-Y. Dummy variable. Okay, ano nangyayari class pag dummy variable? Okay, dali lang class, wait. I'm looking for my glasses, hindi ko makita yung ano, wait. Okay, alright. So, di ba, check natin class yung cross tabulation ito, female at saka male, no? Female at saka si male. So what will happen is that in order for this to be part of your regression, kailangan i-dummify natin siya. When you say dummify, it will be converted usually into either a 1 or a 0. 0 or 1 yan. Para magiging binary yan. Okay. So how is this converted? How many will be the number of dummy variables? Yung dummy variables class, yung dummy will, yung how many will be dependent on the number of levels minus 1. Okay? Levels means the number of unique unique categories. So dito class sa gender, nakita natin na female or male lang yan. So dalawa lang yung levels yan, 2. And then, so minus 1, the number of dummy variables will be equal to 1. In other words, class, ito, papalitan ng isang dummy variable. Isa lang, class, isa. And sa R, anong gagawin niya? Paano niya i-dummify ito? Okay, R will look at the values here. Gagawin niya female at saka male, no? Female at saka si male. So what will happen here is, since female will appear first, this will become the benchmark or the reference. Pag sinabing benchmark to or reference, this will be equated into 0. Okay? So si male magiging 1 siya. Kasi remember, 0 or 1 lang naman, no? Okay. So this will be dummified. Si gender magiging, so ito female magiging 0 to. 0, 0, 1, 1, 1, 1, 1, 0, 0, etc. So notice now, class, you only need one dummy variable to capture all the levels. Diba? Ilan ba levels natin? Dalawa. Ilang dummy variable kailangan? Isa lang, class. Kasi 2 minus 1 class is equal to 1. All the levels will be captured. Makaka-capture si female, makaka-capture si male. Okay? So I hope that's clear, class, no? So I'm going to, again, illustrate, class, what if there were 3 dummy variables? Suppose may ano ka dito, may kunyari, brand, no? Brand. May variable ka dito na brand. Kunyari lang, no? Tapos ito, A, B, B, C, C, A, B, B, etc. No? So we took a look at the levels. Ang level siya, 3. A, B, C. Okay. Now, since this is a categorical variable, this is a factor, this has to be converted by R. So, paano niyo i-convert yan? First, how many dummy variables? How many dummy variables, class? Kung ilan yung levels, 3, A, B, C, minus 1, so there will be 2 dummy variables. Okay? So, dalawa, no? Tanong, sino ngayon yung magiging benchmark? A, B, C. Sino yung alphabetically mauuna? Alphabetical, of course, si A. So this A will become the benchmark now. In other words, this will become 0. Si B at saka si C magiging 1. Okay? So what will happen now is there will be another variable. Kunyari, let's call it brand. So si A, siya magiging benchmark, ano? Magiging 0 siya. So mangyari dito, branch B at saka branch C. Okay. Ganun ang mangyayari, class. Dalawa. No? Now, bakit hindi isasali si A? Kasi makakapture pa rin yun. A will be captured even if you're only introducing 2 dummy variables. Okay, so we don't introduce 3 dummy variables kasi magkakaroon tayo ng problem sa multicollinearity. So when you have a factor, when you have a character variable, R will convert it into a dummy variable, and then the number of dummy variables will be equivalent to the number of levels, kung ilan yung mga unique values niya, minus 1. Okay? So take a look at this class. So si A, ano siya? A is not B, not C. Diba? Tingnan nyo, dalawang dummy variables lang. Si A will be 0, 0. Kasi not B, not C yun eh. O ito, B. Ano siya? B yan. Not C. 1, 0 yan. B ulit to. 1, 0. C. 0, 1. Dito siya, di ba? A. C ulit. 0, 1. A. 0, 0. So take note, kahit dalawa lang yung dummy variables na in-introduce, lahat ng unique values na capture dyan. Okay? So, whatever the number of levels is, kunyari, limang unique values. Then, ang i-introduce lang na dummy variable, it will be only before. Okay? Why 4? Because everything will be captured, even if L minus 1. Okay? Pag mag-introduce ka pa ng isa pang variable, kunyari, meron ka pang brand A dito, tapos ito magiging 1, 0, 0. Okay, magkakaproblema ngayon sa modeling class. Magkakaroon kasi tayo ng multicollinearity. Okay? Alright, sige. So, I have to continue the discussion now. Okay, I hope that's clear, class. So, let me go back to the model a while ago and explain this one. Alright. Take a look at this class. Gender male. Ano ibig sabihin nito? Okay, remember, gender male class. Notice, nagkaroon tayo ng variable na gender male. Gender lang naman kanina yan, di ba? So, ibig sabihin, nag-introduce si R ng panibagong dummy variable, tinawag niyang gender male. Sino ba yung reference sa gender kanina? Kasi female at saka male. Di ba? So, alphabetically, si female will come first. So, this would now be the benchmark. Ang gagawin ni R dito, ito yung gagawin niyang 0. Okay? So, si male ang magiging 1. Kaya nga naging gender male. Ibig sabihin, lahat ng mga males naging 1 ang value, si female naging 0. And take a look at this class. Anong ibig sabihin na to? Notice that this is statistically significant. No? 3 stars, ibig sabihin significant at 0.001. No? Okay, mataas yung significance siya. Okay. And it's 1.76 approximately. Ano ibig sabihin yan? Ibig sabihin niyan, class, so how do we interpret this? This should be interpreted in relation to your benchmark. Sino yung benchmark natin? Si female. Di ba? Kasi dummy variable to, no? So how do you interpret this? How do we read this? On the average, no? On the average, male employees receive $1.76. Take note, this is dollars, no? Dollars to, kasi ang dependent variable natin dollars. $1.76 more than their female counterparts, ceteris paribus, all things being equal. Okay, ulitin ko. On the average, male employees receive $1.76 more than their female counterparts, ceteris paribus. Okay, ceteris paribus siya. Okay, take a look at this class. Civil status single. Let's assume first that this is significant, no? Kasi ito hindi significant eh, no? Wala siyang star. Greater than 0.05 siya. Okay? Remember class, Yung null hypothesis natin dun kanina, okay, so ito kunyari, civil status. Null hypothesis nito, so this is the 6, no? B6. B sub 6 is equal to 0. Kasi yung intercept B0, si education B1. Hanggang dito kay number of dependents B7 kasi there are 7 predictors. No? B62 is equal to 0. Then, anong sagot natin dito, class? Anong inference natin? We fail to reject the null hypothesis that B6, that your civil status is equal to 0. So we fail to reject that. Bakit, class? Kasi ang p-value niya 0.12. Remember, ang rule sa stat class, if the p is low, ibig sabihin ng low, less than 0.05 siya. No? If the p is low, the null must go. Ibig sabihin, i-reject natin yung null hypothesis. Ito class hindi eh. The p is not low. Then, ang conclusion natin dito, we fail to reject the null hypothesis that b sub 6 is equal to 0. Which means there's a strong statistical reason to believe that ano class? We fail to reject this eh. So dapat b sub 6 is equal to 0 nga. Okay? Kasi hindi siya significant. No? 0.12 to eh. However, assuming class that's significant to, no? How do we interpret this now? Assuming that civil status single is significant, so take note class, this is a factor, no? This is a dummy variable. Now, civil status single means that the other factor, yung married, is the benchmark. Kasi si married una eh, class, letter M2 eh, no? So, ganun ang ginagawa ni R, no? Kung ano yung wala dito, class, yun ang benchmark. And the basis of R is the alphabetical basis. So ito, how do you interpret this? Ganun din, class. On the average, single employees tend to receive, on the average, $0.46 less. Less, class, kasi negative to, no? Less than their married counterparts, ceteris paribus. So you're now interpreting this class, itong factor na to, itong dummy variable na to, in relation to your benchmark. Lagi kang babalik doon. Sino ba yung benchmark? So, kunyari, kung tatlong levels yan, tatlong lalabas dito, class. Kunyari, kanina, brand, di ba? Ang brand ABC, di ba? Brand lang muna yon. Tapos, mangyayari yan, magkakaroon dito ng brand B at saka brand C. Okay? Kasi tatlong levels, so dalawang dummy variables ang lalabas dito. And how do you interpret that? Brand B in relation to brand A. Brand C also in relation to brand A. You'll always go back to your reference or reference variable, okay, or your benchmark. Ganun lagi ini-interpret. Ito din class, no? Race white. Assuming na significant to, pero hindi significant, no? Hindi siya significant. Pero assuming na significant to, how do we interpret this? On the average, class, white employees on the average receive $0.11 more. Bakit more? Kasi positive to. More than their non-white counterparts. Yung isa kasi nito non-white eh. White at saka non-white. Okay? $0.11, rinound off ko lang, more than their non-white counterparts, ceteris paribus. Okay? Ceteris paribus. So, ganun class yung pag-interpret nitong mga variables ito. Ito, let's take a look at this. Number of dependents, no? And although class, so sasabihin natin dapat walang meaning to, no? Kasi we cannot reject the null hypothesis that B7 is equal to 0. Okay? Hindi siya significant, no? Although may value siya dito, yet because of the p-value 0.17, okay, we reject the null hypothesis that B sub 7 is equal to 0. Okay? But assuming it's significant, how do we interpret this again, class? Okay. So, a number of dependents in terms of one unit yan, parang child, no? Pag nadagdagan ng isang anak. No? So, how do we interpret this? On the average, okay, one additional child, one additional dependent, okay, will what? Will will mean a 0.146 increase in hourly wage ceteris paribus. Okay? So iba class ang pag-interpret ng factor, ng categorical variable at saka ng quantitative. Okay? Ito yung marginal effect. Ito naman, this is in relation to your benchmark. Okay, so ganun, i-compare nyo sa benchmark. Okay? So, dito class, I have a few more seconds just to end this. Okay. All right, so next meeting class, we're going to take a look at this in greater detail. We're going to take a look at ano tong standard error of the residual. Yung degrees of freedom, by the way, class, how did we get this? So, ang formula ng degrees of freedom is, nag-discuss ko kasi sa kabilang klase ito. Okay, the formula for the degrees of freedom is, asan yung annotation ko? Annotate. Annotate degree of freedom, df is equal to n minus k minus 1. So what's this n minus k minus 1? N is the number of your observations. 526. Okay. Minus k is the number of your predictors. In our case, ang predictors natin, education, experience, tenure, race, gender, 7 sa lahat, no? Minus 7. Okay, 7 lahat ng predictors, and then minus 1. Minus 1 class because it accounts for the degree of freedom loss because we're also estimating yung intercept. Ito yung para sa intercept. So 526 minus 7 minus 1, that's your 518 degrees of freedom. Yun yung class. Okay, so next meeting class, we're going to study this, yung mga other parts pa nito. Okay, we'll take a look at the anatomy of this class kasi we have to understand what everything here. Okay, para pag nakita nyo yan, alam nyo kung ano nangyayari. Okay, so that's our goal for next Tapos we'll proceed further and then actually matatapos natin ang multiple linear regression by next ano pala class take note, di ba may exam tayo sa sa 21, no? Next Monday will be our Monday ba sinabi ko? Or 28? 21 ba or 28? Okay, pag-usapan na lang natin sa sa Thursday. Okay, Monday. All right, let's finalize that on Monday. If ever class ang coverage will be your data structures, yung mga videos niya, tsaka yung dplyr. Hindi kasama si regression. Okay, so let me end recording now. Stop recording.